Hello everyone. So we have discussed about basic routing uh, and how the network layer provides a kind of a common platform due to which we can transfer data across different technologies, from wireless technologies to wired technologies to Ethernet links to some fiber optics to various links, point-to-point links, or using different data link layer and physical layer technologies. We have a common platform which allows in the network layer having a let's say generally based on IP addresses, which allows us to transfer data across this networks of networks, which we call as the internet. So today what we'll do is we'll construct a mini internet kind of scenario, which we also sometimes call as a campus network kind of scenario. And we'll see how we can access some simple services. Okay, we will see how we access some simple services. So first, I've already built up this network. I will explain to you because if I build this network from scratch, the video is going to be very, very long and uploading and sharing will take a long time. But I will explain to you how this network I have constructed. So let's see first. So we have this network. This network is network 1, you can say. This is network 1. This is a network 2. Network 1 has a gateway, which we call gateway 1. Network 2 has this gateway, which we call gateway 2. Basically this interface of the router. Now I have used, I have been using this router, 4331 router generally, but I've used a different router here. Doesn't matter, you can choose the same router also. But why I have used the different router is here you can see this router. It has got many gigabit Ethernet. So when you take, for example, a empty router, it generally it does not have any interface, but you can select from here. These are all the slots available, so you can select as many as you want. This CGE means gigabit Ethernet. As many gigabit Ethernet cards you want to add, you can add. So this gives you a lot of options. You can also use other kinds of technologies uh, as you wish. But I want to keep this network uh, simple so that we get the basic understanding of the entire process. So I am not using different kind of links here, but you are free to experiment with that. For example, in this network, in this entire scenario, this mini internet that we have created, all of the links are Ethernet links. Basically, these links from switches to routers or between routers, I have made them gigabit Ethernet links. But others, hosts and whatever servers we'll discuss, those I have put it at fast Ethernet. So router to router or router to switch, those I have made it gigabit Ethernet. But overall, if you see, the entire network is based on Ethernet. Obviously, you can change it. For example, if you want to change this network into a wireless network, from this switch we have discussed, we have seen before, we can connect access points and then connect these PCs to those access points. So those things you can experiment on your own. It's not a big deal. But let's see what is the objective here. Okay, the first objective here is we'll discuss today in this demonstration how the transport layer, the layer above the network layer, and the one above is the topmost layer, the application layer, how they operate and how we get the services that we use on a day-to-day basis. So basically, we'll check. There's a company. I have a company server I have created. ABCDXY. That is the name of the company. This is the website hosted on this server. The server is nothing but a powerful computer with lots of memory and lots of computational power, lots of RAM, lots of CPU power. Okay. Then I have created a email server and a DNS server, a domain name system server. We'll see what why that is required. And then I have created two other servers called a DHCP, or Dynamic Host Configuration Protocol servers. So let's go one by one. So first, this network, I have made it as 10.1.1.0. This is the network address /24. Okay. These two, gateway 1 and between gateway 1 and internet router, I have named this internet router because it is through this router that we'll be able to access, let's say, different services on the internet. Now you could have multiple routers in between, and then somewhere at the far end you could have all these servers which give you access to, let's say, some company, some email, for example, Gmail you are using, or Yahoo Mail, whatever, and a domain name system server. There could be multiple routers in between, and finally you have all these servers. But you can do all that on your own. To demonstrate the utility and how the things how data is like transferred, this is enough. This configuration is enough. So this is one network, this is another network. Both these networks access the internet services on the internet through, let's say, an internet router. Now this internet router is connected to different servers. Okay. I have created 3 servers here, one for a particular company, which I have called ABCDXYZ company. Then I have created another server for accessing email, just like you have your Gmail, Yahoo Mail, something, or a diff mail. And then is something called a domain name system server. So this router allows you to access the services on the internet. So I have named this as an internet router. So now what I have done, this network, I want to be 10.1.0 network. This network connecting gateway 1 and internet router 10.1.2.0. Then this network, which allows us to access these two servers 10.1.3.0, and this company you can access through this network 10.1.4.0. Then there is another network. Then there is, sorry, this network, which I have given 10.1.6.0 as the network address. And to access the internet router, this link has been put on this network 10.1.5.0. So this is a simplified configuration I have done in the cyclical manner. 10.1.1, 2, 3, 4, 5, 6. That's the cyclical manner. So it becomes easier for us to understand, nothing else. Now, in reality, suppose this is your internet service provider, and this is, let's say, a university, and this is another university. The internet service provider might have a certain range of addresses available with it, and it might do subnetting to give a portion of those IP address to this network and another portion to this network. That comes under subnetting, which you can explore on your own. But to understand this, how we access services on the internet, I'll use this simplified IP addresses and all that, so that it's easier for us to get hold of the processes. So on top of that, what I have done, I have, let's see, show IP route. Yes, so I have enabled RIP in all these routers. These three routers I have enabled routing internet protocol. So this is a distance vector routing protocol, interior protocol. It's not an exterior protocol. Now, in reality, when you have this ISP connecting to another ISP, and then at the very end, you'll have all this. Between these border routers, you could have external gateway protocols and so on and so forth. But it's fine. You can explore all this on your own. This setup is enough to understand the basic processes involved. So now let's go to the first part. What is this DHCP, or Dynamic Host Configuration Protocol? Now I have initiated, I want that this network should be 10.1.1.0. So I have initiated this interface as 10.1.1.1, the first address, this interface. Now all these hosts, previously we used to give manually static address, but I don't want that. I want them to be automatically configured. This is generally what happens when you are connected to any network. You automatically get an IP address. How is that done? That is done through a process called Dynamic Host Configuration Protocol. Okay, and that process is generally hosted in every network by a server. So let's open this server. So what I have, what is this server? I have just taken, what is it? And device, this server, any one of this server I have taken. This is how I have done it. Here you see there are lots of services available. So just go to this, and then you have to fill up this part. So what do you want? So I will delete this now. So let's check what I have done here. Services, DHCP. I have given the default gateway 10.1.1, this. Now, there is something called as a DNS server. We'll come to that. This is the DNS server. Each IP address I have put here. It is in a network which is 10.3.1.3, and this is, if you see, let's see, 10.1.3.1, and that is his email server 10.1.3.2. So 10.1.3.1 is the DNS server, or domain name system server. We'll talk about it. Okay. Now start IP address. What? Start IP address is 10.1.1. So actually it will never be 0. First IP address is never given. Okay. So it will, but it will automatically figure out. Okay. And subnet mask is 255.255.255.0. So from this network address, you can give dynamically, automatically, you can allocate whatever hosts are there whenever they connect, and then you can give maximum number of users. For example, there are, if you exclude the what is called IP, the network address and the broadcast address, there will be 254 IP addresses available. Now this is statically configured with the first address, so 253 are available. So now you may give all 253, or you can set a limit that only 61 randomly out of those 253 addresses, only 61 you can randomly provide to all the hosts connected to this network. That's your choice. You can put this maximum rate. You can also exclude a set of IP addresses and so on and so forth. Those commands are available. If you can check in the internet, you can do all that. But this is what basically I have done. This network, this DHCP server, I have configured. Its service is on. default gateway I have provided, a DNS server I have provided because there is a DNS server here. Okay. Then I have given the start IP address. I have given maximum number of users. You can put it as something 255 or whatever. It will automatically figure out. Okay. So now in this PCs, any of these PCs, if you collect, see configuration. Previously, we used to give static and manually configure. Now I have put this at DHCP. And the settings, what we have given, again, gateway and all that. So the DHCP server will provide all this information to this PC automatically. Even domain name server, everything, whatever information we have put to the DHCP server, it will be available to this PC. The DHCP server will configure all this information on this PC. So what it has done, it has automatically given this address 10.1.1.3 to this guy with gateway 10.1.1.1 and DNS server 10.1.3.1. Similarly, this IP address has been automatically configured. Now, if you had given, let's say, in the DHCP server, where is it? Services. If you had given the start IP address, let's say 10.1.1.20, then it would not have got this address. It would not have got this 10.1.1.3. It would have started after 20, something like that. Maybe it will start at 20. So the thing is, you can use a DHCP server to automatically configure hosts which connect to the network. So in a similar way, I have configured DHCP server too. Let's show you. This network is 10.1.6. DNS server remains the same. Default gateway is this 10.1.6.1. And default gateway DNS, all these are automatically configured. You can see. We did not put any static configuration here. DHCP. It has automatically configured everything. The DHCP server, whatever information you give, using that information, the hosts are automatically configured. If it is mentioned that the hosts will use DHCP. For example, if I change it to static, then DHCP server will not be able to do anything. You have to manually configure. But this is generally what happens. We are, most of us, almost always, we are in DHCP mode. So automatically configure address, and there will be a DHCP server in every network. It will, once you connect to that network, it will automatically configure a IP address to you from the available pool that you have mentioned in a DHCP server. So this is what the DHCP server is doing. It gives you an IP address for that particular network. So now what I have done, we have already, this was in this interface, we have given IP address 1. Similarly, this interface, we have given IP address 1, first IP address of this network. Again, we have configured this link and this link. It's your choice. I have given the first IP address of this network here. Similarly, first IP address here, last IP address here. And then you have these two networks. This network, it is for accessing this company website. This company's website is abcdxyz.com. This company name is abcdxyz. And then we have this network. Imagine this is like Google. You know, we always use Gmail. Let's say this is Google's personal network. Google has an email server for Gmail. Imagine this is how you access that email server of Google. Okay, and I have put it on 10.1.3.0. Again, the last IP address, I have put it here. And whatever the first IP address, I have given it to this guy. The second IP address, I have given it to this guy. It just randomly I have chosen. You could choose other IP addresses, but manually configured. Okay. Now this guy I have given again the first IP address of this network. Now let's see how I have configured this tree. Okay, and what is the purpose? So this is easy to understand. So again, what I have done is, see, if you bring a server, okay, click on in packet tracer. If you see services, one of the services is HTTP. Okay, one of the services is HTTP, and if you connect, let's say, directly a single PC to this server, and you go to what desktop web browser, okay, you can see the web page. HTTP is your, for browsing web pages, you need that protocol. This is an application layer protocol, hypertext transport protocol. Now here this is Cisco is given. If you this is by default it is mentioned Cisco packet tracer or something is mentioned. Some figures are given for Cisco. Now you can change all that by simple this one. You can import some new images and change all this. Okay, what I have done is I have deleted all this. Okay, so I will show you. I've deleted all this, and is the index. I've just changed this index. I did all this. I don't need. Welcome to ABCD. Something I have mentioned like that. Let's see what I have done. So this is HTTP. I have removed all other HTML files. Hypertext markup language is the, let's say, programming language used to create a web page. You can see. So here I've just welcome to ABCD company, opening doors to new opportunities. Just this. I've removed everything else, and HTTP is on. So this is how I've created this ABCD server. Very simple. And what else I have given? Of course, config. I have given it a what? In the fast interface 10.1.4.1 subnet mask, and what? A default gateway. How does this guy get to the other side of the internet or get to any other network? Through this interface of this router, 10.1.4.254. So those are the things I have configured. So similarly, just like this, so I have configured these two servers. Let's first go to the email server, what I have done. So email. So email, just every Gmail, you have Gmail or Yahoo Mail will have a domain name. What is the domain name? The last part. Email, gmail.com. Gmail.com is a domain name. Okay. Then in gmail.com, there'll be so many users. You have, all of you have user IDs. No, for example, what you can set an user ID, user one. So user1 at the rate of gmail.com becomes your email address, and you can set a password. Always you have a password. So I will say user1. If you do that, you get this. You have created an email account in the Gmail server. Okay. So now similarly, what I have done here, I have created, let's go to the email. I have given this email operates in the application layer, two types of protocols, simple mail transfer protocol and POP3. These are two types of application layer protocols used, okay, to operate your email services. So I have created a freemail.com, this makeup hypothetical server I have created, email server. And what I have done, say this PC I have named PC1 of network 1, PC2 of network 1, PC1 of network 2, PC2 of network 2. So I have created just like these 4 users I have created. PC1.n1 password I have put it PC1n1. So it's your choice. But remember this user and password. This will be required. Okay. So once you do that, your email server is set up. So email server is set up, fine. So now let's go back here. So what have we, how do we now access? In the server side, we have created the account. Now in your desktop also, in your system also, you need to create an account. So if you go to desktop, email, see, you can configure email. I have already configured, so this window you get. If you have never configured first time, you will get a displayed like this. So you put your name, whatever name you want to put, your email address, this, incoming mail server, freemail.com, outgoing mail server. So I am using the same server for incoming and outgoing. You could use different also, but this is generally, it will generally be the same. Okay. So this server I will use. And then user one password. This should be the same as we have configured here. Whatever user ID and password you give here to create an account, here also in your PC, you should have the same user ID and password. So this is how you do in all these hosts, you configure your email accounts, okay, or email services. This is how you will access email services. Now the last thing is DNS server or domain name system. So what is domain name system? So when you access the internet, okay, what do you do? For example, google.com or any website, any company, anything, ABCD, XYZ. For example, here I put .com. Now, everything in the internet, it is what is called transfer. Data transfer happens from point to point using IP addresses. So there is for every name, but we cannot remember all these IP addresses of all these company. IP addresses are not easy to remember. We remember easily names. So domain name system provides a mapping between IP addresses and the names that we have given to easily rememberable names. So what we do here is, for example, I will show you. Let's delete this. We don't need. What I have done here is, this is a DNS server I have set up. In the DNS server, I have put this record. You put a name, you can create multiple, as many as you want. abcdxyz.com. What is its IP address? This is its IP address. So this is a mapping. Similarly, freemail.com. So if you remember when we put this email, configure email, I have given incoming mail server, outgoing. I have given it, instead of an IP address, I have given a name. Okay, because it's easier to remember. But you could also give an IP address here. But generally, we don't know all these IP addresses. We don't remember all these things. But you could also give if you know. But generally, we don't. So we will give gmail.com or something else. Okay. So this is where we need the DNS again. The freemail.com is having IP address 10.1.3.2. We have mapped it, created a mapping between IP addresses and names. Okay, and domain names, which we call. So now, having done all this, let's see now what happens. Let's try first to access, let's say, a web page. We have never pinged this guy. We have never accessed the web page of this guy, this company. Let's try and see what happens. Okay. So I will go to simulation mode. I'll go here and I will do what is it? Web browser. So I want to do from this PC, I want to access this web page of this company. I will do abcdxyz.com. What happens? First thing, ABCDXYZ. I don't know what's the IP address of this. This guy does not know. So he starts a DNS query, domain name system query. When he starts this domain name system query, where should that query go to? Well, we have already configured in the DHCP server the DNS server. DNS server is 10.1.3.1. Okay, and that knowledge is provided to this PC also. The DHCP server has configured everything necessary. So when the outbound PC, outbound packet, it puts destination IP as 10.1.3.1. I want to know what is the IP address of abcdxyz.com. And obviously, this is a fresh network. Nobody has transferred any packet. So ARP process has to be started because I don't know the MAC address of this gateway. So ARP process started, goes, receives the MAC address. Okay. DNS query now can be completed. It goes there. Then by this time, most probably the DNS query times out. Most probably. Okay. Oh, no. What has happened is this guy does not know the how to forward this packet to this guy. The MAC address is not available. Its ARP cache is not filled up. So it needs to again restart or start an ARP process to find out what is the MAC address of this DNS server. So it starts, comes back. Yes, now it gets to know what is the MAC address. Now this STP and all are going on. Let's see. Anyhow, let's see. Maybe there is an error here. It's a simulation. Let me see if RIP is sometimes, maybe I have forgotten, show IP root. It seems that yeah, 3.0, 4.0, what is got 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. It's there. Let me see here. So IP root, is it? Yeah, it should be 3, 4. All are, seems like RIP is there. With this router, show IP root. Yeah, so this is also there. So let's not worry too much. Let's see. Again, if we try, most probably it got timed out and all this other things are yeah. So we can do, what we could do is DNS, ICMP, all those things we can keep, and miscellaneous all this. Okay, doesn't matter. Let's start once again. Okay. Oh, it was able to see, finally we got welcome to ABCD XYZ company, opening doors to new opportunity. Let's try once again. Let's try once again, because sometimes it happens that we miss uh, we miss the track of the events. So let's try once again. Let's see from here if we ping. Okay, web browser. What do I want to do? I want to go to abcdxyz.com. Fine, let's go. Again. DNS is started. See, now let's look at one of this DNS. Okay, because once you got DNS, see one important thing here. This DNS query, it is trying to find out the IP address of a particular domain name. In this case, ABCDXYZ. This DNS process, uses UDP or user datagram protocol in the transport layer. Okay, it uses user datagram protocol. We will see that why does it? Because this is not very critical info. If you are using file transfer or something, okay, then those are very critical information. Okay, but DNS, even if it is times out, domain name system, if it times out, you could again resend. It's a simple information you need. So DNS generally uses UDP. UDP does not have any acknowledgement or anything. Okay, but once DNS has been received, let's see what happens. OSI, the PC 2 N1. So this guy, what it tries to do is HTTP client makes a connection to the server. Okay, and what it tries to do, it tries to set up a TCP connection. Okay, you will see here now instead of UDP, a TCP connection will be made before HTTP can be started. Okay, a TCP connection, and a TCP, you know, is a reliable protocol. UDP is an unreliable protocol. No acknowledgement happens, but TCP is a reliable protocol. So it first tries to set up a connection by a three-way handshake. So what does it try to do? It tries to make a connection to 10.1.4.1. This is the 10.1.4.1. This is the IP address of the ABCD company website. So how does it do? If you see here, when it does not need to send sequence number, any arbitrary it could do, but generally probably it starts with sequence number 0. Okay, it sends a empty data. Okay, it sends an empty data packet. What is there in the empty data packet? Destination port is 80. Why? Why is the destination port 80? Because we will try to, let's see, in the IANA website, we'll go to HTTP search. If you want to access HTTP service, then your port number should be 80. These are well-known or well-defined port numbers. Okay, and so 0 to 1023 or 1024, those port numbers are reserved to access specific services on the internet. Okay, but you could use in your PC any available port number. Okay, apart from this 0 to 1024. So here, for example, 1025 randomly. You could have selected something else, so 2013 or something, but you have used a random port. But you know, to access this service, HTTP service, you will need to connect to a destination port, which is 80, as given in this IANA website. Okay, you can check IANA website, Internet Assigned Numbers Authority website, to find out which application layer protocol needs which port number in the transport layer. Okay, so HTTP is the application layer protocol. It uses transport control protocol using port number 80. If it had used UDP, it would have used again 80. There are some others, for example, FTP, file transfer protocol, it would be completely different. 20 is the port number. Again, we will see email and other things have different. So anyhow, it sends a connection request, TCP connection request with sequence number 0 first time. Okay, it could use any other random sequence number also, between 0 and 65,000 something. Okay, but let's say it starts with 0. Acknowledgement number, obviously there is no question of acknowledgement, so it is put here number 0 here. Then it will go there. Let's see. Now spanning tree protocols are going on, doesn't matter. It reaches switch 1. There is a switch 1. Finally, it reaches the router and it reaches the server. Okay. Now at the server, it has reached the internet device. It is the server. Okay. Okay. The server. The server, it got this TCP request. What did it get? Connection request. Okay, three-way handshake will take place. So it has received this sequence number 0, acknowledgement number. It has also received that this guy can accept a window, data packet or data block, whatever you want to say, of size maximum 65,000 something. Okay, that much data it can receive as a single block. Okay, so what we'll do it outbound. Let's see outbound what it does. TCP accepts a window size. Okay, and then it gives a maximum segment size, all that thing. It sends an acknowledgement. Okay, what does it do? It received what? It received a packet with sequence number 0. So now it says, I am expecting next time if any packet arrives from you, a segment arrives from you, it should be an acknowledgement number 1. And then it replies back with its own sequence number 0. Please go through TCP header and TCP protocol if you are confused about this. Okay, and it also advertises that it can only accept data of this much size. Fine. So this is what goes on. So then this response is sent back. This response is sent back and it reaches there. Now what it does is a TCP inbound. Okay, this is the TCP. It got acknowledgement number 1, sequence number. What will do in the outbound? It received what? It received the sequence number 0. So what will it say? Next I want is acknowledge, means next packet if I ever get from you, it should be a 1 more than the sequence number received, acknowledgement number 1. And then its first segment had sequence number 0. It has updated its sequence number to +1. So sequence number 1. In all this, you can see this response that it has got from this server. It has got the response. The server has flipped the port address. Its destination port is 1025 from which it's sent, and source port its own port in which is hosting the HTTP service is port 80. It just flipped it. And on the other hand, what it will do, it will again flip that. Destination port is 80 and source port is 1025, the one it had initially used. So this is now, it is sending this TCP. This is a third phase of the three-way handshake. It is sending this. Once this reaches here, TCP handshake is complete. And immediately, it also sends, along with this, is HTTP request. I want to access the internet. So it has put the same thing, sequence number 1, acknowledgement number 1, okay, and send this HTTP request to the server. HTTP client sends a HTTP request to the server. Okay, so let's see what happens. TCP and HTTP are following one another, if you see. So here at abct.com receives this frame. This is a TCP inbound, and basically the connection request is complete. And the HTTP guy also receives a request. What does it receive? Sequence number is 1, acknowledge, and the data length is 100 or 100 bytes. Data length is 100 or 100 bytes. So if this is the data length, so what will be, because the data length is 100 bytes, when it sends an acknowledgement, it will be 101. So I've received everything properly. Okay, and it's first because it is the first HTTP segment that will be sent. Its sequence number is 1. So like that, now it sends back. Now it has received. Let's see. I think we should be able to. Yes. Welcome to ABCD company, opening doors to new. We can now read this web page. Now, as soon as this is complete, this HTTP request is complete, the TCP connection will close again by a three-way handshake. So sequence number what? 101. Acknowledgement number 267. So probably in this HTTP request, data length 266 was received. So you can figure out, all the information is given here. You can do your additions and figure out what is the acknowledgement number, what is the sequence number. So I will leave all that exercise to you. You have to read about the TCP header and how it works to figure out all this. But this gives a good demonstration of how TCP is working. So now what will happen? This is going to be a closure request. You see, fin wait. So fin flag will be open. Fin means finish. So here, these flags are there. These flags are there. So these flags, one of these flags, I think this one or this one has been set to 1. That means I want to close this TCP connection. So it goes there. It receives, it acknowledges the fin request to close the TCP connection. And in that same data packet, it also says that I also want to close this connection. And it responds back. And that's it. So TCP is closed. So this is how you will access a web server on the internet. Any website, when you access, this is what basically goes on. Obviously, lots of routers will be there in between, and you can, if you want, you can create a very complex network in packet tracer itself. But this is the fundamental way how things happen. So now, let's stop this. Let's try to access this email. I want to send an email, let's say from here to here. Let's say what happens. I will go to here. Where email is? Yeah, email. Where I have already configured. So I want to compose. So I want to send it to this guy. So and his email address I know. I know that this is pc2.n2 at gmail.com. I will say test email. Hi, how are your studies going? Enjoying your university life? Regards, PC1. What? PC1N1. Okay, so let's send this. This is your friend in another university. You are studying in this university. You want to send an email to your friend in this university. So let's send. Now again, DNS. Why? Because I am using a domain name freemail.com and I don't know what it is. What does freemail.com, where it is? DNS is initiated. Gone. Here. It goes to DNS server, gets the information. It knows that it has to reach 10.1.3.2. Let's see. It is 10.1.3.2 it has to get. So if you see the TCP packet, now what will be? See 10.1.3.2 destination, it now knows. So it will try to create now a TCP link to this email server. So first three-way handshake will take place. Again, ARP is needed here because what happened is this guy does not know the MAC address of this guy. So it gets to know. I think by the time TCP might have been what do you call timed out. So it sends another TCP. It reaches now. Three-way handshake will take place. Three-way handshake. It has initiated a TCP. And now SMTP or Simple Mail Transfer Protocol. This is the process used in the layers and application layer to access internet. Now, if you see source port this, destination port this. So if you go to, let's say SMTP, SMTP uses port number 25 and uses generally this TCP protocol, transmission control protocol. So what it has done, port number 25 and source port randomly it has chosen. Apart from 0 to 1023 or 1024, at first 124 port numbers, you can choose the rest quite randomly. So with this, it is going to now send a request. Okay, it is going to send this email that you had sent written to this server. So let's so it has reached, and then SMTP will probably inform the PC that yes, your email has been received in the server. SMTP tells that device received the SMTP packet. So it has acknowledged that your email has reached the server perfectly. Okay, then it will close the TCP connection. So that's what it will happen. Okay, closes the TCP connection. Okay, on port 25. Again, three-way handshake probably will happen. Both sides closes the connection. Okay. Both sides will close the connection. Finish. Now, so sending mail to send success. So this your email has reached the email server. Now let's reset simulation and go to real time. Okay. So this has reached the server. So from the server, the other party can access it. Okay. So let's do here. Go here and we go to, let's say, email. See, it is seeing the test email has been received. So let's try to receive. Actually, I had done this before. That's why it was already flooded. But if you type receive, so it's like refreshing periodically. Our email, whatever email softwares are there in your computer, refreshes periodically, so it happens automatically. But you can manually also do refresh. Okay, so I manually refreshed it to receive if there is any email for me. So now what, the domain name system, because it has to receive from an email server, it does not know the IP address, then address resolution protocol and so on and so forth will happen. Let's go on. TCP is initiated to connect to the email server. A three-way handshake will go on. Then POP. POP is used in this case to receive. SNMP was used to send and POP is used to receive. If you what is called disable one of them, then probably the same protocol will be used to send and receive. But here in this case, they are using POP to receive the mail. So let's go on. It's the same process. Yes. Now I should be able to see the email. Enjoying our university life. This is the email I got. I think previously I had also tried this. Okay. So this is what it is. This is how things proceed. Then there will be a three-way TCP handshake. Actually, it's, you can say, four-way. What this server is doing is, during acknowledge, this is saying a connection closure or disconnect request. It acknowledges that disconnect request, and in that same segment it says I also want to disconnect. But you could do, they could have done it separately also. This server could have done it separately also, that in two different messages. First it will acknowledge the disconnect request, and then immediately it will send another request for disconnecting. So both way disconnection must happen in TCP. So finished. PC2 now acknowledges the disconnection, and that's finished. So this is how data is transferred generally using TCP in the network layer and IP in the internet layer. And in the application layer, the most of the time we are using hypertext transfer protocol for browsing web pages, and email, in which we use SMTP or POP3, those kind of application layer protocols. On top of that, you could also create a FTP server, okay, file transfer protocol server. Okay, FTP, just simple commands you can use in the command line to access those files hosted in this server. So for example, here, for example, this company could also use an FTP. These are all these files here. Okay, you could use some password and this, and you can use simple commands in the command line like FTP cisco.com, something like that. of FTP abcdxyz.com, it will automatically connect to this server. Then you can try and copy files from here to here, and you can see how that happens. You can do all that on your own. You can uh, there are enough videos and simulations all over the internet. So this is how basically you access some important services, basically email and browsing web pages across the internet. So this is a kind of a mini internet simulation we have done. I would encourage you to change all these links, make these links different, make some of this wireless and so on, and observe how things go. So that will be far more realistic. For example, these links will probably be wireless links using access points. These might be fiber optical links, some will be serial links, and that will become more realistic. Similarly, you could put more routers in between and then configure uh, external or border gateway protocols in them. So that will be quite a realistic thing. But this more or less gives a good understanding of how we access data on the internet. So that's all. So thank you.